Okay, let's look at building some piecewise functions from scenarios. Michelle and Nancy's parents have told them they must exercise each day after school. They have allotted 1 hour each day for their workouts. This week, they decided to describe their workout, create a graph to map their routine and to track their speed, and then write a set of equations for each graph. They like to run, walk, or bike each day in their neighborhood. From Michelle and Nancy's house, the Dogs Are Fun Park is 2 miles away. So right here is Michelle and Nancy's house to the Dogs Are Fun Park is 2 miles. Uncle Bobby and Aunt Jessie's house is 3 miles. So from their house to Uncle Bobby and Aunt Jessie's is 3 miles. Well, if you look at what we've written down thus far, if Michelle and Nancy's house to the dog park is 2, and then to Bobby and Jessie's is 3, that tells me that this distance from the dog park to Bobby and Jessie's, that's 1 mile. Okay, now let's see what else we've got. Grandmother lives 1 mile away, so from Michelle and Nancy to grandmother, we're at 1 mile. To ride the bus to school in the morning, they have to walk half a mile. So from Michelle and Nancy's house to the bus stop is half a mile. And because the whole distance is 1 mile, I know that this distance is also half a mile. The Lakeview Rest Area is exactly halfway between Dogs Are Fun and Uncle Bobby and Aunt Jessie's house. Okay, so we know that this is a 1 mile distance. So this is half a mile, and so is this. Okay, so based upon the verbal descriptions of their exercise for the day, determine the distance time graph that matches the description and complete the piecewise defined function for the distance time graph. Match the graph of the speed and complete the piecewise function for the speed, and fill in the blanks for the description as you work through the activity. Okay, so we're going to have to leave this because we're going to have to refer back to this information often as we do Monday through Friday's exercise routine. So let's see what we have in number 1. It tells us on Monday, Michelle and Nancy left their house, ran to the dog park, stopped for 10 minutes, then ran to Bobby and Jessie's for dinner. Okay, we're going to have to find the rates for both of those, but we really can't find the rates until we know what the graph looks like and what our equations are. So with that being said, let's go ahead and draw our piecewise graph in this little blank right here. Now we're going to allow the x-axis to be our time in hours. Now they have to exercise for 1 hour every day. And if you'll notice, we're going from 0 to a half to 2/3, 2/3 to 1. We also know that they stopped and rested for 10 minutes. So from 1/2 to 2/3, that's 10 minutes right there. So we can do 6 because 1/6 of 60 minutes is 10 minutes. So I could let this be 1/6 of an hour. This will be 2/6, which is 1/3. 3/6 is a half. 4/6 is 2/3. 5/6 is 5/6, and then 1 hour. So by using fractions, everything is still in terms of hours. Now over here, this is going to be their distance from home. All right, and so let's do 1 mile in miles. I didn't write in miles. Okay, so I'm going to do 1 hour, or 1 mile, 2 miles, 3 miles, and 4 miles. And I'm going to put my little halves in there as well, just in case I need them. Okay, so Michelle and Nancy left their house and ran to the dog park. If you look, Michelle and Nancy's house to the dog park is 2 miles. So interval number 1, which is when they ran from their house to the dog park, is going to go from 0 to 1/2. That means from 0, it takes them 30 minutes to get from their house to the dog park. So at half an hour, they'll be at the dog park, which is 2 miles from home. So they started at home, 0 minutes, 0 miles, and they traveled to the dog park Took them 30 minutes to get there, and they're 2 miles away from home. So this is going to be 1/2 and 2. Then it says they stopped for 10 minutes. So 1/2 to 2/3 is a 10-minute interval, because each interval is 10 minutes on this line. 10, 10, 10, 10, and 10 until you get to 60, which is your hour. And so this will be 2/3 and 2 as well. Okay, and then ran to Bobby and Jesse's house for dinner. So after they rested for 10 minutes, they ran to Bobby and Jesse's house for dinner at a rate of blank. Now, let's look and see how far away they are. They're at the dog park, and Bobby and Jesse's house is right here. So they're running from the dog park to Bobby and Jesse's house. Well, that's just a mile away. Okay, so they're already 2 miles from home. So when they're a mile away, they're a total of 3 miles from home. So this will be 1 and 3. Okay, so now let's fill in our rates now that we've got all this information. So on the first interval here, you have change in y, 2 minus 0 over 1/2 minus 0. Copy, change, flip, and that'll give you a rate of 4 miles per hour. On this interval, being horizontal, your rate is 0. Your third interval, the change in y, 3 minus 2 is 1, over the change in x, 1 minus 2/3 is 1/3. Copy, change, flip, and you're going to get another rate of 3. This is 3 miles per hour. So as we go over here to write our function, we know on our first interval, we have a speed of 4 miles per hour. That's going to be my slope times my time. So since we started at 0, 0, we know we don't have a y-intercept. Now looking at your second interval from 1/2 to 2/3, that's a horizontal line. That's going to be at y equals 2. Y in this case is d, so d equals 2. And they gave us the equation for the third interval. Now we calculated the rate to be 3, so we know that this is true. And then they used the point right here, 1 and 3, to do t minus 1 plus 3. When you do a speed graph, you're just taking the 3 speeds from this graph, 4 miles per hour, 0 miles per hour, and 3 miles per hour, and you're putting them on the same type of graph. We're still going to have time. We'll have 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. So this is my time in hours still. Now y this time is not going to be the distance from home, it's going to be our speed. So our speed in miles per hour. Okay, so we're going from 0 to 4 miles per hour, so let's do 1, 2, 3, 4. Okay, so in my first interval from 0 to 1/2, I'm going 4 miles per hour. So from 0 to 1/2, I'm going 4 miles per hour. Now on my second interval, from 1/2 to 2/3, I'm going 0 miles per hour because I'm resting. And then on my third interval, from 2/3 to 1, I'm going 3 miles per hour. So 2/3 to 1. I'm going 3 miles per hour. So my equations on my first interval, when we are between 0 and 1/2, is going to be d of t equals 4. My second interval between 1/2 and 2/3 is d of t equals 0. And my third interval between 2/3 and 1 is d of t equals 3. Now on the next one, it says on Tuesday, Nancy and Michelle were at grandmother's house when they began their exercise. So this time, let's go ahead and do 0, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. So this again is my time in hours. So let's do, so this is my distance from home in hours. So once again, let's do 1, 2, 3, 4, and we'll add to it if we need to. Okay, so on Tuesday, Nancy and Michelle were at grandmother's house. So if you'll notice, once again, there's a miles difference between home and grandmother's house. So we're not starting at 0, 0 this time. We're starting a mile away from home. So at 0 minutes, we are already 1 mile away from home. They left grandmother's house and first walked home at a constant rate. So they're going to walk home from 0 to 1/2. So when they walk home, we know that we are now 0 miles from home. Okay, let's continue. When they got home, Mom told them to go walk the dog. They were home for 10 minutes, so from 1/2 to 2/3, they stayed home and they didn't go anywhere. And then they left for the dog park. So once again, look at your little map you made out. So from their house to the dog park is 2 miles. Okay, so they're going to travel from here 2 miles away from home from 2/3 to 1. Okay, and this is what our function is going to look like, our piecewise defined function. Now let's make our equations. So on our first one, let's go ahead and find the change in y. So that'll be, we've got 0 and 1, and then we've got 1/2 and 0. So when you do change in y, that'll be 1 minus 0. Over change in x is 0 minus 1/2. So that's 1 over negative 1/2. Copy, change, flip, which will give me -2. And then it doesn't really matter, I would use this one. So you'll have t minus 0 plus 1. And then in our second interval, of course, that's equal to 0 because it's a horizontal line on the x-axis. Now for our third line, we've got 2/3 and 0. And then we have 1 and 2. So when you do change in y, 2 minus 0 is 2. And then change in x, 1 minus 2/3 is 1/3. So copy, change, flip, that'll give you 6. And then you'll do t minus 1 plus 2 for your equation. Okay, so if you go over here and fill in your information, they left Grandma's house and first walked at a constant rate of, now the slope of this line is -2, but your speed needs to be positive. Then they waited at home for 10 minutes, and then they walked to the dog park, which will be your third interval. The slope of the third interval is 6, so that means that they'll be going 6 miles an hour there. So as we go over here and we prepare our speed graph, this will still be time in hours. So we've got 0, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. Okay, over here we're going to have our speed in miles per hour. So if you'll notice, the smallest speed, of course, is 0, and we'll go to 2 and then to 6. So let's do 1, 2, 3, 4, 5, 6. So in our first interval, we have a speed of 2 miles per hour. So 2 miles per hour on our first interval from 0 to 1/2. Now on our second interval, we're at 0. So from 1/2 to 2/3, we're at 0 miles per hour. And then on our last interval, we're at 6 miles per hour. So 2/3 to 1, we're at 6 miles per hour. So according to the speed functions, the first one has a y-intercept of 2, the second one has a y-intercept of 0, and the third one has a y-intercept of 6.